Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. Ladies and gentlemen, sometimes you do your research right at the beginning of the show because I'm a professional, and you start reading about new diapers and mini colons, and you're just like, I'm in the right field. This is where I belong. So today's stories are going to be all over the place, in a good, not in a colon way, but in a good way. So joining us today is Ralph Bond. He'll be joining us here in just a moment to talk all about a number of stories. And if you want to find out more about those, computeramerica.com will have everything that you need. And that will have Ralph, that will have all of his past shows, future shows. And of course, it will have links to anything and everything that you need to find over on our site. And, primarily it's going to be the show notes, because if, Ralph does a good job of hitting the highlights, but then there's always a little bit more. So if you want to check that out, check out the show notes. In the meantime, though, why don't we go ahead and bring Ralph on? Again, I'm just flabbergasted by stories number 3 and 4. Yeah, it's and honestly, everything from story 2 to 3 to 4 kind of, have a loose connection with each other. So, ladies and gentlemen, if sit back and relax as we kind of get into this. So, Ralph, welcome back onto the program. He is, of course, our science and technology trends correspondent, and we are ever happy to have him back on. Ralph, how you been?
I'm doing great. And again, you're right. We've got a very diverse grab bag of really fun stories that are all about trends in science and technology and so forth. And that's a key thing to keep in mind, folks, especially if you're brand new to the show today. Welcome, of course. Please come out to computeramerica.com. Get the show notes that Ben's mentioning, because what I do is I put the highlights of 4 articles, but we embed links, and sometimes I add tutorial side notes that aren't part of the articles that help embellish or to fill out some things that may not be familiar to you. And what Ben and I do every Friday is look at where we're headed. And that's the trends part of it, where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it, all across the board today. And today's 4 stories really reflect the crazy wide range of what we do each week. And we will leave you, I guarantee, feeling encouraged about the future, thanks to science and technology.
Absolutely. Yeah. It's so hard in today's day and age to, go to any of the major news sites and not see something that's trying to make you angry just because. But hey, this whole segment is just here to, like Ralph said, make you happy. And story number 1 should make a lot of people happy because, let's face it, Ralph, in terms of technology, and there's some larger conversation about what is the quote unquote most impactful if you really want to break it down. I think a lot of there's a strong argument that one of the biggest changes in our lifetime has been the battery. Just kind of breaking it down to its core parts. The battery has enabled so much in our lives, but they are unfortunately a lot of times disposable, or they break down. They're just not they're not really a renewable thing. It's more like once it's used, you can recycle it. Hopefully you do, and we encourage that you do. But by and large, once it's broken down, you just got to replace it. Well, story number 1 may be a way that, hey, less batteries in a landfill, hopefully none in a landfill. But anyways, a second life for batteries. That's the hope. So story number 1.
Yeah, this is a great one. Comes from interestingengineering.com. Headline, a simple injection could bring aging batteries back to life. Sometimes I take liberties with the headlines to make them a little more explanatory, in my opinion. But great article. We've got a link in here, illustrations and so forth. If you're listening to us as a podcast, again, please come out to computeramerica.com and get the show notes so you can get the images and details and so on. So here we go. We know that lithium ion batteries are the most common type of rechargeable batteries, powering our daily lives from smartphones to electric cars. But over time, they lose their ability to hold a charge, making them less efficient and reliable. This is because they lose some charged particles or ions that store and release energy in the battery. Okay, so I think we all kind of know that. But what if you could replenish those ions and restore the battery's original capacity? That's exactly what the researchers from Toyota Central R&D Labs in Japan have achieved using a single-step process that could reduce waste and boost the supply of batteries needed for fleets of electric vehicles. And I'm going to segue here for a second.
Mm-hmm.
One thing this article is not going to do for you, and what Toyota is not doing for the rest of the world at this point, is divulging the recipe of this secret sauce they've come up with. Okay, so the article here is not going to give you insight on that. That's proprietary, and they're going after patents and all that sort of stuff.
I'm sure once it's ready to leave the lab, they'll let everyone know where they can buy it. But yeah,
well, where they can buy it, they may
Yes.
not give you the recipe. It's sort of like Colonel Sanders' recipe. Okay. So the researchers injected a special substance, which they call a recovery reagent, into battery cells. This substance triggered a chemical reaction that produced more lithium ions and electrons, the two types of charged particles that enable a battery to store power. Wow. By adding more of these particles, the researchers were able to reverse the degradation of the battery and restore 80% of its original capacity. The restored battery also maintained its performance for 100 charging and discharging cycles. Now, stress again, early research. 100 charging and discharging cycles is good. It's better than nothing, but it's not, it's really not going to make the world change in itself right now. Remember, early research. They'll keep pushing this. I'm sure they'll achieve greater results down the road. And the researchers tested their method on small and large batteries, including those used for automotive applications. And then, Ben, sometimes we have to do a reality check, as they do in the article here. However, the technique is not a magic bullet for all types of battery degradation. It only works for batteries that have lost their ions due to repeated charging and discharging, not those that have suffered structural damage or other forms of deterioration. So if a battery's been punctured or something like that, this isn't going to help. It also requires a way to diagnose the battery state and determine whether it suits the injection, whether it really qualifies for the injection. And there's a great also supplemental link in this article to a publication called New Scientist, where there's even more information. So as the news outlet New Scientist reports, the Toyota Research Group has filed a patent application for their work, which has attracted interest and funding from other companies and government agencies such as the U.S. Advanced Research Projects Agency Energy. So a lot of interest in this, a lot of notoriety in the community of scientific people working on batteries. And again, I stress the show notes have that New Scientist article link as well. So go and check this out. I wish I could tell you more about the secret sauce, but we'll have to wait and see how it plays out.
Yeah, some of the diagrams that are included in this are so like simplistic that it doesn't really it doesn't really tell you much. Though I will say that I know last week we talked about self-healing batteries. And now this is not and the self-healing one, by the way, was a completely different kind of battery. I'm assuming this still works with lithium ion. Well, I'm not assuming, it says lithium ion, but that one was like lithium sulfur. Right.
Yeah.
But still, Ralph, this is like humans die from so many things, so many complicated things. But let's say we found a cure for heart disease, for instance. It may not be like if you get hit by a car, that cure for heart disease probably won't help you. But if we can cure heart disease, that's a vast majority of people out there, and really, a vast majority of the batteries out there. Even just from last week, we mentioned that lithium-ion batteries have a life cycle of 500 typically. Adding another 100, that's 20% longer lives. That's 20% less batteries that you need to power something. These are really important numbers for really large applications. It's still it's very impressive. that
Yeah.
and of course the pedigree, I guess, that the research is coming from also makes a big deal too. This is not some little startup or lab research. This is, well, Toyota, and it is lab research, but
Yes.
it's Toyota. So
Yeah, and one thing too about extending the life of battery through this injection process, I'm going to assume that you could keep it injecting it. So you inject it, you get another 100 cycles, and then can you inject it again? And how difficult is it to inject? Could they finally make a car battery there where you could go to a filling station or something and get the little shot and get going again? I don't know. Just many unanswered questions.
Ralph, if nothing else, like right now, let's say you have like a Tesla, for instance, and it's time to swap battery, or you have a RAV4, as you've mentioned, that when it's time to replace that battery, they'll say, okay, we can swap out the battery, or we can do this maintenance on it, and it'll get you another 20%, and you can put it off another 2 or 3 years, and it's going to be a lot cheaper. Little stuff like that is going to start adding up in people's lives.
Agree.
There you go.
And again, early research, they can advance this down the road. It might be much more efficient, much more powerful. Who knows?
True. So story number 1, story number 2, and this one is fun because when it came to, let's talk about the Romans. When it came to the Romans, if you ever wanted to, really, really mess up a people, you not only killed them, which is all well and good, but you also salted their fields, and made sure that they could not reclaim their fields because there was a buildup of salt, and they had to go somewhere else. It was kind of irreversible. Well, scientists have seemingly done the impossible, and somehow, I don't know. I'm looking forward to this article. They're using salt water, but they're not killing everything. So good on scientists.
Yeah. This one's great. It comes from AgNews, ag being short for agriculture news. And this has really, really caught my eye. Scientists are growing crops with salt water that could help save us from starvation. So there's a lot of implications in that headline alone. Pretty interesting stuff here. And this is a story coming out of Israel. I know right now Israel is a very difficult and sensitive topic. So put all the horrible stuff going on in Gaza off to the shelf here. We're talking about scientists and what they're doing. And there's some great scientific work going on in Israel. So salt water is bad news for most crops, but not for a series of tomatoes, alfalfa, onions, and rice sprouting in a lab in Israel.
Neat.
These crops, this is cool. These crops don't just grow, they thrive on salt water. Over the last 4 years, SaliCrop, that's SaliCrop, SaliCrop, has been testing its seed enhancement technology on tomatoes in southern Spain, where devastating drought has triggered severe salinization, the process where soils become too salty for crops to grow efficiently. With SaliCrop seeds, however, participating tomato farmers have seen a 10% to 17% increase in crop yields. Now, so what we're saying is you'll find out modified seeds, creating plants that can deal with salinization. Not only have they been able to survive, but they're increasing yield. This is like a double win.
I'm actually curious about that a little bit, Ralph, because maybe their crops are less productive. So let's say they lose they're like 50%, and then they increase it by 17%. Is it increase from the reduced amount because of the stresses, or is it over, like you said, a perfect crop and then 17% increase over that?
That's a fair point. Yeah,
curious, but still, any increase just means food on people's plates.
Yes.
So it's good.
Yes. And this is something the article did a really good job. I probably, if I had written the article myself, I would have put this at the beginning, but it says here, Spain is just one of many places worldwide with a serious salinization issue. A perfect storm of years-long irrigation, warming global temperatures, and sea level rise have made, get ready for this, 20 to 50% of irrigated soils worldwide too salty to be fertile. I hope it's a horrifying statistic. I hope it's wrong, but I don't have any reason to believe it is. 20 to 50% of irrigated soils worldwide too salty to be fertile.
So,
oh my God.
So it kind of makes sense that, if you're going to, plant your crops, you need a source of water, and you're probably going to plant near water. So if there's saltwater intrusion, which I think a lot of people know about, Ralph, it kind of makes sense that, the farmland is going to be near the water anyways, and any change in that water is going to affect those crops, obviously. So I think it's more like, it has to be accurate because that soil just has to be near water. So makes sense.
Yeah. Yeah, yeah. And the salinization problem is costing the global economy, according to this article, an estimated 27 billion per year in lost crops. So there's your problem. That's what's going on. So scientists at SaliCrop are developing an army of resilient crops that can grow under the stresses of our changing world, like saltier soils and warmer temperatures. SaliCrop is working to bring its solution to 8 different countries right now and is already fielding calls from seed companies in Europe, India, and Africa, and are seeking immediate solutions to improve, all these countries, of course, seeking immediate solutions to improve their crop yield. So this is a similar story in the sense to the one we just did at the beginning, in that they're not divulging the exact recipe of how they're pulling this off, of course, but it is a really interesting development to help deal with a changing world where our soils are becoming more saltier soils. So big problem and an interesting solution.
Yeah, I assume it's like so many other things in agriculture. And I know that, we talk about construction every now and again here on the show, but farming and agriculture has a lot of technology that goes into it too. There are massive advancements in, basic food staples that help a lot of people stay, not starve. And they're happening all the time. I'm sure research like this is happening all over, but still great to highlight SaliCrop. And I keep wanting to say SaliCorp. SaliCrop.
Me too.
And still very, very cool with what they're doing. And of course, working all over the world, as their article kind of says. So, okay. Story number 2. Story number 3, the weird stuff. Okay, so SaliCrop has created more food. Well and good. People don't finish what's on their plate, which is, hey, stop eating when you're not hungry. That's fair. Well, scientists, and I'll go ahead and let you read the title, but what do you do with the extra food? And I'm sure everyone immediately thought diapers. So yes.
Yes, right, sure.
It's crazy.
Well, you might think of diapers as the end result of a food intake process. I'll stop there. So this comes from ZME Science. That's the source here. The headline: Scientists turned food waste into plastic-free diapers and sanitary pads. Okay, I could not resist that headline. How could you? This is actually a really interesting story.
Okay, so Tibi, and Tibi's the author of this article. I sincerely apologize, but big courage for Mr. Tibi Puiu to write an article about diapers. So good on him. I'm proud of him.
And sanitary pads.
Yes, good on Tibi.
By the way, being the grandparent of 3 nearly 5-year-olds, and they're way past the diaper thing, but we've got a little boy in the group who's almost 3, and he's still doing the diapers. Believe me, this story resonated to me. Yeah. My history over the last few years with diapers alone. Oh my God. Anyway, and the thought
it's such an incredible expense, and almost like I think when parents come out of that phase, they're like, I can't believe I used that many diapers. It's an incredible amount.
Well, and you think too, the horrible part of it being we're going to learn the diapers have a lot of plastic components, and it's going into the landfills because you can't recycle that dirty diaper.
Yeah.
So anyway, with all that negativity said, let's get into the positive story. So a fellow named Antonio Capezza, I hope I'm saying that right, Capezza, a researcher in the polymeric materials division at the KTH Royal Institute of Technology in Sweden, that's a mouthful, has found a way to replace various polymer fibers in diapers and sanitary pads with porous materials made of biomass waste. In specific, It's the protein from the waste of the food and agricultural industries that would have otherwise been discarded. So this protein from food waste and agricultural byproducts that otherwise get discarded, they figured out a way to make alternatives to the plastic used in diapers and sanitary pads. So it's really cool. So here's the problem. Lots of plastic materials in diapers and sanitary pads can't be recycled. And below, in the show notes, come out to computeramerica.com, get the show notes. I've got some optional details to explain exactly what the plastic elements are in both diapers and sanitary pads. If you want to dig deeper into that, come to the show notes. I'm not going to spend time on the show right now going through that, but be as it may, a lot of plastic elements in diapers and sanitary pads that can't be recycled. Okay, so that's the problem. So this is the problem. And that's why this new research from the Royal Institute of Technology in Sweden is so promising. And it gets double points, as the author of the article said, for being a happy accident. In other words, the solution is the result of an accident. One day, Capese, this professor, was breaking stuff on purpose to teach students what could go wrong in a lab. In one instance, he introduced unwanted humidity while making bioplastic filaments from proteins. The wet cotton he used in this experiment caused the mixture to foam. Later, when the product dried, the foam that is, the research team realized that the material was super porous, capable of soaking up a lot of liquid like a sponge.
He really speaks to me as not just a scientist but a human who makes a mess and doesn't clean it up. He's like, I'll deal with that later. And hey, happy accident.
Yeah, exactly. And this serendipitous moment opened the door to a new line of research. Instead of cotton, which needs bleaching and other chemical interventions to be useful in sanitary products, the researchers looked to natural molecules left over from food and agricultural waste. Things like zein from corn, gluten from wheat, and natural antioxidant extracts. And in the show notes, you can find out what zein from corn is, because I didn't know what it was, but you can check that out if you want to. Come out and get the show notes. But going on with the story here, the researchers combined proteins in varying ratios and added water and bicarbonates like baking soda as foaming agents, glycerol as a sweetener to act as a plasticizer, as a catalyst, as it were, and natural extracts for preservation. They then employed plastic industry methods and equipment. Now, that's important. So their little recipe here doesn't require all new equipment in the production side of it. So again, they employ plastic industry methods and equipment, such as extrusion equipment, similar, think of it like a pasta maker, to create components typical in pads, sanitary pads, and diapers. This process allowed them to produce both foamed filaments and flat sheets. Using these methods, they crafted 3 components needed for diapers and sanitary pads, 3 replacement components made from agricultural and food waste, folks. Think about that. Here's the 3 components they're replacing. First, a dry to the touch non-woven layer to let liquid pass through quickly. 2, a fluffy porous material that absorbed liquid efficiently, and 3, waterproof films to safeguard outer garments. Wow. And there's so much more in the article. You want to go dig into it deeper, get those show notes. But wow, this is so cool. And think about someday maybe we'll have something that can truly biodegrade and so forth.
Yeah, truly disposable, and not just and it's actually biodegradable and stuff like that. I mean, if you're watching the video portion, you can see that there. All the different layers. Weird that it came from an accident, but at the same time, like nothing that was that. Sometimes Ralph, you kind of list off like the steps that they kind of go through and some of the concepts. Yeah. When you got to using baking soda and glycerol and extracts from other things, bicarbonates, like none of it's exotic stuff, but I guess just putting it together in a new way is really the breakthrough here. So very, very
well,
cool.
And I think another salute to this research team in that they thought to themselves, sure, there's probably many other possible applications for this bio material that they've created. But they must have thought to themselves, where's the worst problem? Diapers and sanitary pads. What a mess. And
My
so I salute them for targeting that as an application. I think that's just really, really smart.
For sure. My my and just got a puppy recently. Piddle pads, dog training pads and stuff like that would be another good application. So, I could think of so many more, but that's a good one. Diapers is certainly a good one. So there you go. Story number 3. Story number 4. This one is actually kind of reminiscent of other stories we've done in the past.
Yes.
Where you can ask for volunteers, and people are going through horrible diseases, and you can kind of figure out a treatment that works for them. But of course, then you have to extrapolate and try to hopefully find more people that have any number of horrible diseases, and you just have to kind of wait for your chance to come along to do your research. It's time consuming. It's of course cost of just having to wait is in human lives. But being able to recreate cells and even organs, and I think in the past we've heard of things like kidneys and hearts and so many other important organs that they can just kind of recreate and test en masse. I think very similar to what we're about to hear about in story number 4, but for really one of the most dangerous forms of cancer out there, and may potentially lead to a cure even faster. So yeah, Ralph, yes. Story number 4.
Yeah, story number 4 is great. And again, if you're new to the show, often what we do on these Friday segments is end with something from the world of medical technology and science advancements. And so that's why you'll see that happen every Friday, usually without fail. So story number 4, the headline here is Lab-Grown Mini Colons Advance Colorectal Cancer Research. And once again, sometimes I take a little liberty with the original title to make it a little more explanatory. This comes from medicalexpress.com, and it's a story that was posted by the Federal Polytechnical School in Lausanne, Switzerland. Great story, and there's a video embedded in the show notes. You can check that out as well. And there's a supplemental article published in the publication called Nature, also to fully flesh out this story. So here we go. In a breakthrough for cancer research, scientists at the Federal Polytechnical School in Lausanne, Switzerland, have created lab-grown mini colons that can accurately mimic the development of colorectal tumors, offering a powerful new tool for studying and testing treatments for disease. And Ben, I want to amplify on something you were saying a moment ago. Mm-hmm. In the world of medical research, it's so encouraging because it used to only have animal testing, or you had human participants and this sort of thing to try your experiments on and so forth. And that's always problematic. But if you could have organoids, lab-grown organoids, or in this case, a lab-grown colon tissue to experiment on, you accelerate the process, you simplify the process, and so on. That's why this is so important. This is such an important story. And again, to your point, is just another example of advancements in this field of research using lab-grown tissues. So in a significant leap forward for cancer modeling, scientists have combined microfabrication and tissue engineering techniques to develop, to develop miniature colon tissues that can simulate the complex process of the initial formation of a tumor, cancer tumor, in the body. So instead of having to deal with tissue that's in a person's body, we can do the same thing, but with a lab-grown tissue in the lab outside of the body. And the key here is they've created a way to study this process outside of the body with high fidelity. They were able to create tumors that closely resemble those found within the body. So a little more detail on this. These mini colons are topobiologically complex, meaning they not only replicate the physical structure of colon tissue, but they also mimic the cellular diversity present in the actual colon tissue during healthy and diseased states. Oh, wow.
So a great analogous.
Yeah, it's just super. And this part here, you're going to love this, Ben. Another important feature of the lab-grown mini colons is that they can be induced to develop tumors at will and in targeted areas. A massive advantage for cancer research. Ha! The researchers were able to turn genes that can be activated or turned on under specific conditions using optogenetics. Optogenetics. This cutting edge technique uses light to control biological processes such as gene expression. Wow, there's a lot going on in that paragraph alone. By integrating a blue light responsive system into the mini colons, the researchers made them undergo controlled genetic alterations that can lead to the development of cancer. The result? This can reveal tumor evolution with unprecedented details, so they can get the pathology or the progression of how a tumor develops.
Yeah,
gives them this amazing ability.
Yeah, the article even, well, the press release actually, no, I'm sorry, it is the article from Medical Express, actually has the video that shows, I'm assuming this is the tumor here on the right.
Yes.
If you're watching the video portion, where you can see it kind of start out kind of small, and it starts to progress and progress and get bigger and bigger. So it's not just like, oh, there's a tumor, let's start working on it. It's, we can induce and watch it grow, which is, of course, if you want to, let's say, inhibit the growth of tumors, that's, you know, that's very significant. So very cool.
You're right, Ben. You're right. And being able to study in detail in a lab situation like this, the progression of the cancer, how it grows, as it were, is super, super important. I mean, very, very helpful.
I mean, even this 22-second video embedded in this article is, you know, I just read the subtext, 38-hour time lapse. Like, that's a lot of video footage, and, you know, very crucial. Like, 2 days, you know, sounds like a long time, but, you know, but I don't know. It's very, very cool. So there you go.
Yeah, it's impressive. It's impressive. So a little bit more about this optogenetic approach. So it says this optogenetic approach allowed the scientists to induce targeted change in specific cell populations within the mini colons, mimicking the localized onset of colorectal cancer in the body. And as one of the lead researchers noted, quote, this basically allows you to watch tumor formation in real time and do very detailed analysis of a process that's very difficult to study in a mouse. He used an animal example. In other words, it's so difficult to do this when you're dealing with live animals or you're dealing with humans and so forth and so on. What a great thing that they're able to do this with lab-grown mini colons that are replicate the actual colon tissue of a human, and to be able to study the progression of the cancer, to learn things that may help us fight this dreadful disease. So we leave you on an upbeat, encouraging note, as we always do with all the stories every Friday.
For sure. It's really amazing, you know, the research going into cancer. And I know that, you know, for really my entire life, you know, they've really been focusing on like AIDS research and cancer research. It's amazing, Ralph, that it's eluded, you know, so much funding, so much research, and true cures seem to be really evasive. But, you know, they're making progress every single day. So there is hope that cure will come down.
Oh, yes.
So,
yes.
Story number 4, always great. And ladies and gentlemen, if you were checking out the show notes, you may notice there's a section called Honorable Mentions. And those are stories that we don't do on the air because, you know, we try to keep this concise, you know, try to keep it down for you and for your listening pleasure. But these are stories that still deserve, you know, some level of notoriety, because it's not that they're worse. It's that, you know, we kind of have a, you know, we have a time slot. So Ralph, let's read the nice folks, the headlines at least of the honorable mentions.
Oh yeah, the first one's a hoot. If you're listening to us as a podcast, please come out to computeramerica.com. Get the show notes, if nothing else, to see the picture of this story here. Headline: Constructing a self-balancing screw wheel bike. Comes from an outfit called Technobob. But the picture alone is just amazing in the video. I mean, this is just too weird. I can't even verbally describe it.
I've seen some of these wheels on like robots and robotics. It's essentially a wheel that can go in any direction. It's crazy.
Yes.
And of course, seeing it on a bike is just a whole different level of fun. So
Yes. So please come out and check that out. Next honorable mention headline: researchers report new fuel refinery concept that could power airplanes, without traditional dirty fuel. Designed to be simple, low cost, and robust. A nice advancement from an outfit publication called The Cool Down. Check that out. That's important. And next story is critical minerals recovery from electronic waste. A few weeks ago, we did a story about recovering gold from motherboards and that sort of thing. This is related to that. This comes from the Pacific Northwest National Laboratory just up the road in Washington State from where I live. And that's an important story. And then this one is too funny. From CNN. Fascinating and funny all at the same time. Parrots can play tablet games for enrichment. Now researchers are studying how to improve them for the birds' use. You'll find out the parrots are using a little game where they pop bubbles on the screen with their beak. Mm-hmm. Parrots are very, very smart people. Real smart.
I had a family member that of course had an African gray parrot. It's they live as long as humans. They are as smart as children, and hey, if you can make their lives better, more enriched, then I think it's just a win all around for these for these animals. So, ladies and gentlemen, the music means that we are going to go ahead and head out. I want to thank Ralph so much for bringing these stories to us, working on these show notes. He does an amazing job all the time. And if you want to find out more, computeramerica.com. We'll have the show notes by the time that you hear this. It'll be up on our site. And ladies and gentlemen, until next time, I want to thank you so much for tuning in. Catch us here. More Ralph Bond, more everything. Everyone, computeramerica.com. Catch you next time. Bye, everyone.